Welcome guys, welcome to In 5 Minutes. In this presentation we will see how actually the product of sum form is solved or analyzed. So it is abbreviated as POS, product of sum, that is also called as the max terms in the digital techniques or digital logic. We enter 0 in the K-map for a POS logical expression. So let us consider an example function which is of three variables a, b, c, and this is how you represent the POS form: pi and capital M. And what are the max term present with these equations? They are 0, 1, 2 and 5. If you have a general expression, let us say y is equal to a plus b, c plus a bar, b plus c bar, and if you product them, these are nothing but the sum terms. This is the sum of a and b, sum of c a bar, sum of b and c bar. You are going to obtain the product of these three terms. That's why it is called as product of sum. So you can easily reduce this expression. So let us solve an example in POS form. So here once again there is a function of three variables in which there are four max terms are present: 0, 2, 4, 6. So inputs are a, b and c. So let us write down for these three inputs, let us write down the decimal equivalent. So there are three inputs, there will be 8 combinations starting from 0 to 7. So decimal equivalents are 0, 1, 2 all the way to 7. So these are the decimal equivalent for these respective input combinations. Now we have also mentioned that we will enter 0 in the K-map. This is the standard notation for any POS form. We enter 0 in the K-map, but output y is present for these four max terms: 0, 2, 4, 6. So we will put output as 1, but while entering into the K-map we will put 0. That we will see in the next slide. So first of all, put the outputs 1 for the max terms which are present in the expression. So max term 0 is present, max term 2 is present, max term 4 is present, and max term 6 is present. So for these four I will put 1 in the output section, and otherwise I will put 0 for the rest of the terms. Now for these ones I will write down the expression. Means what? Since this is a POS form, so I need to have a sum for first, sum for second, sum for third, and sum for this fourth combination, and this sum should be equal to 0. So whatever the 0 terms are there related with the 0th max term, I will consider them as it is 0, and whatever the term which is having 1 in the input combination, I will put it bar. So let us go from one by one. So first combination, 0th max term, all the three inputs a, b, c are 0, so I will put them as it is. Since I need to enter 0 in the K-map, so I will put a, b, c as it is, and I will sum them. So this is nothing but my first sum. What about my second term? Second term is a0, b1, c0. So I will put a as it is, I will complement the b, and I will put c as it is. Since b is 1, I will treat it as b bar, and I will sum them. So if you see carefully, the sum of each max term is 0. So in the first case, 0 plus 0 plus 0. In the second case, 0 plus b bar, b is 1, so b bar will be 0. So 0 plus 0 plus again c is 0. That's why the whole summation will be 0. For the fourth max term, I will write down a bar plus b plus c, and for the sixth one I will write down a bar plus b bar plus c. So these are the four max terms I have got, and these max terms are represented as capital M suffixed to its decimal equivalent. So there is a capital M and its decimal equivalent is 0, so it is capital M0. This is the max term corresponding to the 0th location. since 0, 2, 4 and 6 are present, so this will be 0, M2, M4, M6. Likewise there will be present M1, M3, M5. These bits also be present with this. So how you will write down the final expression for this one? So final expression for function of three variables a comma b comma c, that is equal to product of all these sum terms, that is nothing but a plus b plus c. So there is a product of all these four sum terms. So once again this is going to be your canonical form. Canonical means what? Each of the term having the combination of all the three inputs present for this particular function a, b, c mentioned here. So this is a pose form.